So now let us implement retrieve. The first cycle of CBR is called retrieve, where we are going to execute the retrieve cycle in order to find the most similar case to the new case from the case base, meaning that this is the case base that we have for our case study, right? This is the case base that we have, right? It consists of four old cases. In the retrieve cycle, we have to find the most similar case to the new case, meaning that which one from these four old cases is the most similar to the new case. What do you think? Do you think case 1 is the most similar to the new case, or case 2, or case 3, or case 4? In order to identify the most similar case from these four cases to the new case, we have to implement the similarity measure. Do you still remember? In calculating the similarity measure, we do have a local similarity and a global similarity, where the local similarity is executed in order to calculate the similarity degree between each attribute value or feature value of the new case and the old case, while the global similarity is a build-up of a local similarity. So now firstly let us discuss how the local similarity is going to be conducted in our case. First of all, before we start calculating a local similarity, my dear mates, you still remember that in a local similarity we have two types of a value. We have a discrete or continuous formula. How can we identify which formula we have to implement is based on the type of the value for the attributes in the case study. So in our case study, here are the attributes, right? Attribute 1, attribute 2, attribute 3, attribute 4, attribute 5. Each of these attributes has a values. If you can see the values of the attributes of the old cases and the new cases is represented in continuous type. So we have to implement the formula of continuous. So here is the formula. I already got it from the slides. So similarity between attribute A of the new case and attribute B of the old case is equal to 1 minus absolute value of A minus B over range, where A always representing the attribute value of the new case, while B is the attribute value of the old case, and range is equal to the value difference between upper and lower boundary of the set. First of all, let us know how we can identify the range. So actually range can be indicated to the following equation. Range equal to max minus min. What do we mean by the maximum and the minimum here? We mean the maximum value and the minimum value for each attribute in the old cases. So let's us see how can we get the range here. So firstly, I do here range equal, we give a space here to write. So range, we said the maximum value and the minimum value for each attribute in the old cases, right? This is the attributes, right? And this is the old cases. So I do table here, then I find this is the attribute 1, right? It's called dam water level, right? So I have to identify the minimum value and the maximum value for the dam water attribute, dam water level attributes in all old cases. So what is the maximum value here? If we look, maximum value among these values here, what is the maximum value here? of the dam water. If we notice the maximum value 29, this one, right? 50, right? Minus the minimum. What is the minimum value here? The minimum value is this one, right? 27. 27.01. So will be equal to 2.49. This is the value range for first attribute, which is a dam water level. So I'm going to highlight it with the red, so it will be easier for me to be recognized. Then we move to the next attribute. Next attribute here for the second attribute, which is Bahang. The maximum value for the Bahang here is 13.09, right? Minus the minimum value. It is the minimum value is in the case 4, which is a 10.11, right? So equal to 2.98. Very smart in the math. And my students of my sections already know that. So this is for the second attribute. Now, I forget to highlight it to the red, so it will be easy for me to be recognized. Where is the red? Here. So now I have to calculate for the third attribute, which is soil. For the third attribute here, so the maximum value here is 13.14, right? Minus the minimum value here is 20.99. So this will be equal to 9.41. So now I think it's really clear to you how you can calculate the ring, right? So you can pause this video and calculate the ring for the fourth and a fifth attribute, which is Bikan and Gambang. Don't worry, I will be waiting for you. So now again, welcome back. So now check your answer for the rings. You should have the same value for the ring for the third and the fourth attributes. So here, how do we calculate the rings? So the rings is already clear to you. So now let us calculate the local similarity for the attributes value of the new case with a case 1. So meaning that we are going to find the similarity degree for this features value, for each feature values of this or attributes values of this new case with the attributes value of the case 1. So meaning that firstly, I am going to find the similarity between the first attribute, which is a dam water level attribute value, which is a 29.15 of the new case with the case 1, which have the attribute dam water level have a value of 29.26. Then we will find the local similarity between the second attribute Bahang that has the value of 12 in the new case with the Bahang attribute in the old case, which is a case 1, that have a value of 11, 16. Then a third attribute of the case of the old one with the third attributes value of the new case by using this formula. So now I'm going to write here retrieve cycle. So I'm going to do this retrieve cycle. So I'm going to do the similarity. I'm going to write here the local similarity, right? For case 1, right? So let me get this one. Will be here. So here will be ls is a similarity between between the first attributes value of the new case and the first attributes value of case 1, right? So I'm going to write here first attributes of the new case, which is dam water level. So I'm going to indicate it with the first D, dam, D for dam, W for water, and level is L. Dam, for this is the first attribute, right? Of the case, of the new case, right? New case and S. A new case, as I represented here, new case. So the similarity between the first attribute, which is a dam water level of the new case, and the first attribute, which is a dam water level of the old case, which is a case 1, right? Case 1. So I'm going to say C1. Let me represent case 1 as C. So it will be clear that C1 is representing 2 case 1. Then equal to 1 minus absolute value of A minus B, right? A is representing the attributes value of the new case. So here we are going to take what? The value of, for the first attribute, which is the dam water level of the new case, which is a 29.15. This is the value for the dam water level, which is the first attribute of the new case, minus B. P is the value for the first attributes of the old case, which is a case 1, right? Because we are comparing with the case 1 here. So which is the value of the dam water? This is the case 1, right? So I'm going to highlight the case 1 here. So I'm not going to forget. This is the case 1 that I am comparing, right? Here. So what is the value? So here is the dam water. In the case 1, the value will be 29.26, right? Divided by the ring. Here, we are calculating the similarity for a dam water level, right? What's the ring that we already calculate? Is 2.49, right? So I'm going to write here 2.49 because this is the ring for the water attribute level for all cases, not only for case 1, for all cases. Remember, the ring value will be calculated 1 times for all cases. So 2.49, and the output value will be 0.904. This is the similarity degree between the first attribute, which is a dam water level of the new case, and case 1 dam water level attribute value. So we can say that then we have to calculate LS for the second attribute, right? So I'm going to do the same, but I don't know why I got this red color. So I'm going to choose red. Okay, LS similarity for second attribute. What is the second attribute? Is Bahang, right? I'm going to find the similarity degree for Bahang attribute value of the new case and Bahang attribute value of a case 1. So I'm going to write here Bahang attribute value of the new case and new case NS, for example, and Bahang attributes value of the case 1, C1, right? Case 1. So will be equal to, let me give a space to you here so it will be easy to you to understand. Will be equal to 1 minus absolute value of, what is the absolute value, what is the value of Bahang attributes in the new case? Here it is. This is the attribute. This is the Bahang attribute in the new case, right? Have a value of 12. Then will be 12 minus the value for the Bahang attribute in the case 1, right? Here is the value of the Bahang attributes in a case 1, right? So will be 11.06 divided by the ring value of Bahang attributes. What is the ring value of Bahang attributes? When we divide, here it is, right? 2.98, right? Will be equal to after we do this calculation by using the calculator, we'll find the output is 0.685, right? So this is the similarity degree between Bahang attribute value of the new case and Bahang attribute value in a case 1. Then we have to repeat the same things for all attributes value. So now we move to LS. This is the LS of the first attribute. This is the second attribute. 2 LS1. Here, sorry. And here should be LS3, right? Do I have this space? Here will be LS3 for attribute 3. So will be similarity between the third attribute, value, which is soy. The soy attribute value of the new case and soy attribute value of the case 1, right? Case 1. So it should be capital S here. Okay. Then equal to the same thing, 1 minus absolute value of, what is the value of a soy attribute in the new case? Is 20, right? This is the soy attribute and the new case is 20. So 20 minus the value of the soy attribute in case 1. What is this? Is the attribute, soy attributes. What's the value in a case 1? This is case 1, right? So will be 13.14, right? And divided by the ring value for attribute 3, which is soy, right? This is the soy attribute, which is the ring when we calculate 9.41. Delete this result. So for example, first I will try, firstly I'm going to calculate the absolute value here, right? 20 minus 13.14. Absolute value, meaning that we don't care about the negative value. Even though we get here a negative value, always the outcome of absolute is a positive. So here 20 minus 13.14, it will be minus 10.14, right? But since we do have an absolute here, so we will have 10.14 divided by 9.41. So then this one also will be equal. Then I will do the 10.14 divided by 9.41. It will be equal to 1.105. Then 1 minus 1.105 will be equal to minus 0.105. That's why we got a minus value here, meaning that we get the minus value because of this. But here, even though we got a minus value, because 20 minus 13.14 will be minus 10, but we do have an absolute value. That's why we got 10.14 instead of having minus 10.14. So I'm going to highlight this one as red again. Okay. Then ls. And now I'm not going to do for the fourth and the fifth attribute. So you are going to do, so just pause this video and then do your calculation and then check with my answer. So now here is the local similarity degree for the fourth attribute, which is Bakkan. I name it here as a PEK. And local similarity degree for Gambang. So you can compare your answer with me. But here I recolored, where I recolored the output with the blue because I want to use it later in the global similarity. So you can check your answer. I use the same formula that I already explained in calculating the LS1 and LS2 and LS3. So now, since we have already calculated the local similarity for all attributes value of the new case with the all attributes value in the case 1.